Let's solve this Leetcode question. Here we are given S1, S2, S3, three strings. Now we have to form S3. While from S1, S2, we can break S1, S2 into substrings. Then we have to merge those substrings and form S3 while maintaining the relative order of S1 and S2 substrings. Okay, now I will discuss this example, then it will be better here. Okay, here we are having this one is S1, this is S2. Okay, then we can break down into in this part, like this is one substring, then this is one substring, this is one substring, then this is a one substring of S2, and this is one substring. Then arranging in A, then string D, B, B, C, then B, C, then A, then C. I think, yeah, that's the correct order. This one, this one, this one, this one, then this one. Okay, this one, this one. So 1, 2, 3, 4, 5. Okay, one starts from here. This is 3. This is 5. This is 2. This is 4. Okay, you can see it is like it's increasing. It's increasing from while. Okay. One thing for sure, like S3 size will be like size of S1 plus S2, then it will be valid, or else it cannot be valid. Then this relative order has to like maintain. Okay, right now first I will explain how I will solve this question in recursion. Okay, then first say we are having S1, S2, S3. If the size of this thing and size of this thing does not add up to the size of this thing, that is false. Then okay, let's imagine that we are merging, which let's say we are merging some this thing, this some index of this thing, some index of this thing, some index of this thing. I like index, like denoted this is a x index, this is n, this is n. If m is already S1 size, then what rest remaining of S2 has to be this thing. Like let's say S1 is this much, S2 is this much, and S3 is some string like this. Already this much merged, and we formed S3 this much, then this much equal to this much. It has to satisfy, like let's say it is AB, then this part has to be AB or else to be false. Same goes for like reverse. Already S1 existed, then the remaining part of S1 has to be this part. When the conflict arises, like when we are having, if the S3 some we are at some x index of S3, S3x index, if does not match with S1's m index, where we are like S1's m index or S2's n index, then this is false. If this thing existed, this character does not match with this character, or already S1 or S2 existed and the remaining character of S1 does not match with S3, that will also false. Whenever there is a like, if S1 m index equal to S2 n index, and that is equal to also S3's like current index x we are considering, then we have to call for like, we have to increase this thing. There will be two branches. Like first we will consider S1's m will consider, then we'll call for m plus 1, then x n index, then x plus 1 index. We'll be matching this index, or else we can branch out, like we have to branch out. The answer can come from any of these, m comma n plus 1 comma x plus 1. Mn like represents here like till what index we have considered. Like okay, now let's code this part in recursion. Okay, I have to pass S1, S2, S3. Okay, initially I have to pass everything 0, like till now not considered anything. Okay, while writing code, I will explain once more again. Okay. Now first, if the string length is not matching, then directly return false. Okay, then we have to return. Let's say we are at like our index. At right now, I'm writing best case. Like if we are already reaching S3 slash index, like S3 this much string. Let's say this is something like, let's say last character is like the index, like we are reaching this index, then already S3 form, then we have to return. Like while we are going in this manner, like we'll match S3's character with S3's character, S3's character with S1 character and S2 character. Whichever matching will move forward, or if those both are matching, then we'll call both. Like we'll move forward by making S3. Okay, if id equal to S3 dot size, return true. Now let's say S1 adjusted. If n equal to S1 dot size. Okay, here n means S1's index, n means S2 index, and IDX means S3 index. I'm considering in this manner. If S2n is not equal to S3 IDX, return false. Or now we have to call the recursion. Okay, both increasing one by one. Okay, now let's say we are adjusted S2. Then what is rest remaining? That has to come from S1. If that does not match, then return false. Or else move forward. You have to increase one because it's considered, and remain same. IDX plus one because it's considered. Okay. Now S1 S2 both are adjusted. Let's say now our character matching with S1 also S2. Then we have to call for both. Okay, S1, no, S1 A equals to S3 IDX and S2A equals to S1 A. Okay, this thing done. Okay, now S1 adjusted, S2 adjusted. If both are matching, now we have, if these conditions are not satisfying, we have to check if it is either matching with S1 or either matching with S2. If S1 equals to S3 IDX Now checking for S2 if it is matches with S2. Okay, if this does not satisfy, return false. Okay, let me check if it's coming to this point. It's true. Okay, let's run. Let's find out if any error is there. Oh, spelling mistake. Okay, probably get TLE because it's normal recursion only. Yeah. Now let's try to memorize this. Okay, we will be getting hundreds of length, like 100 character we can get expect. These two character, like two variables are changing. This is the summation of this m plus n, then it's a 2D DP. Okay, now let's do. I'll be storing -1 initially. If this -1 means it's not calculated, or else 0 and 1. 0 means false, and 1 means true. Okay. If dpi j, oh, not dpi j, and mn n is not equal to -1, return dpm n, or else I just have to, wherever I'm returning, that I have to store. Just copy paste. Okay, let's check. Yeah, accepted. Easy recursion. I'm just memorizing that. Thank you.